Refrigerant temperature readings at 4 locations are mentioned over here. T1 is after compression, T2 is after condenser, T3 is after expansion, and T4 is after evaporator. Pressure gauge readings for the suction side of compressor and discharge side of the compressor are mentioned over here in PSI, means pound per square inch. Energy meter reading in kilowatt hour for the compressor is mentioned, also for the heater. Now here in this case we take this last row for the calculation purpose. So we need to plot the vapor compression cycle for temperatures, means T1, T2, T3 and T4. So these 4 values we use for the location or to locate the 4 points of VCC. In order to calculate energy consumption of compressor, we take difference between this final and this initial reading. Similarly, we calculate energy consumption of heater by taking the difference of the final energy meter reading and this initial energy meter reading. So here is a sample calculation of actual COP. Here refrigerating effect is obtained in the form of heater energy consumption. So here in the water calorimeter we maintain the temperature by adjustment of heater thermostat. So during that, heater energy consumption is taking place, that is equivalent to the refrigerating effect, means output of the system. So it is given by this formula, that is final energy meter reading minus initial energy meter reading of the heater divided by time in R. So by putting the values from the table, this is a time in a minute which is converted into R by dividing it by 60. So we get here thermal load which is given to the system as a refrigerating effect in kilowatt. Compressor energy consumption, means input to the system as a work, is also calculated by using the formula. In this we put the values for the compressor, and also here we get compressor load in kilowatt, that is input to the system. Now actual COP is a ratio of refrigerating effect divided by work. So here we get value of actual COP. Sample calculation of theoretical COP includes, here first of all we need absolute suction pressure. So it is calculated by taking pressure gauge reading. So here for the calculation of absolute suction pressure, here atmospheric pressure is added to the gauge pressure. So here this is a suction, compressor suction pressure, that is a P1. Now here the reading is in PSI, that we have to convert into bar. So this is a relation for the conversion, and this is a atmospheric pressure. So we get suction pressure P1 in a bar, that is absolute suction pressure. Similarly, compressor discharge pressure, that is absolute value, is calculated by putting the discharge pressure, that is gauge pressure, in PSI, conversion into bar plus atmospheric pressure. So value of P2 we get in bar. In order to plot vapor compression cycle, we use pH chart of refrigerant. So let us understand the chart. So here it consists of saturated curve. So this is a bell-shaped curve which consists of left side, that is called as saturated liquid line, right side, that is called as saturated vapor line. This is a critical point. Corresponding pressure on the pressure scale that is called as critical pressure, and corresponding temperature is called as critical temperature. Significance of critical point is that vapor compression cycle plot should below this critical point, because above the critical point condensation of the refrigerant is not possible. Now, because of this bell-shaped saturated curve, this total area of the pH chart is divided into 3 regions. Left side region is called as subcooled region. In the bell-shaped curve, this is wet region, and right side is superheated region. Now here are the various lines which are of constant value. So this is constant pressure line, which is horizontal. Vertical line represents constant enthalpy. This is a constant temperature line, which is in vertical fashion in subcooled region. It becomes horizontal in wet region and falls down in curved manner in superheated region. Isentropic line means constant entropy line is going in upward direction in inclined way. This is curved line, that is density line. In some charts, this line is given as a constant specific volume line. Now, let us see the procedure of plotting vapor compression cycle on this chart. So first of all, we take here P1 pressure, which is calculated, and draw the horizontal line. Then we take discharge pressure of the compressor in a bar. For that also we plot the horizontal line. So here we get these 2 lines. Now this is a liquid saturation line. On this line we locate the condenser temperature. So we take from the observation table condensation temperature, condenser outlet temperature, which was about 41 degrees Celsius. So we get here intersection of this vertical temperature line to the saturated liquid line at 41 degrees Celsius. This is one point we get. Similarly, here this is a temperature line which is here. So here we take temperature after evaporator, that is about 16 degrees Celsius. So here 16 degree Celsius line means which is between 0 and 20 degrees Celsius, and it is near to 20 degrees Celsius. So this constant temperature line and this suction horizontal pressure line intersect. There we find the one point. So this point is of evaporator exit or compressor suction pressure or compressor entry point. Now through this condensation point on the saturated line we draw vertical line. So this line will meet to the pressure line at suction and discharge pressure line. So we find here on these both side intersection points. So here on the discharge line we find point number 2, and on the suction pressure line we find point number 3. From point number 3 we draw the horizontal line which is cutting to this temperature line. This is a point number 4, that is entry to the compressor. From this point number 4 we draw the line which is parallel to these constant entropy lines. So this line will meet to the discharge pressure line, that is horizontal line, and here we find this point. That point is a point number 1. So that is what exit point of the compressor. So in this way we get plot of this vapor compression cycle. Now here in this case the sequence of the cycle is 1, 2, 3 and 4. Now from these points we project the vertical line towards the enthalpy scale, which is at the bottom. So here we find for point number 1 enthalpy H1. Similarly for point number 3 we find enthalpy H3, and for point number 4 we find enthalpy H4 in kilojoule per kg. Now here 3 to 4 process is evaporation process. So in the evaporator we find refrigerating effect, means cooling effect. So we can calculate refrigerating effect by using the formula, that is H4 minus H3. Process 4 to 1 is a compression process. So in this compressor work is done. So formula for compressor work, that is W, which is equal to enthalpy difference, means H1 minus H4 in kilojoule per kg. So from the pH chart now, enthalpies which are obtained, these are enlisted here. Now theoretical COP formula is ratio of refrigerating effect to the work, means H4 minus H3 divided by H1 minus H4. Putting the enthalpy values in the formula, we calculate theoretical COP. So in the results we find theoretical COP and actual COP value. If we observe these both values, then we find in the conclusion that theoretical COP is always greater than actual COP because of reasons, that is loss in compressor line, pressure drop in condenser line, and pressure drop in evaporator line. So at the end of this session we can explain practical relevance, importance, and the procedure of determining performance parameters of vapor compression refrigeration system. You can also determine theoretical and actual COP by using vapor compression refrigeration test rig. If you like this video, please subscribe and share. Thank you.